Do you know what an airport, a retail store, a university campus have in common? They all have a digital twin. Bert Van Hoof is the CEO of Willow these days, but he's also one of the most prominent thought leader when it comes to digital twins. And you agreed to come on the IoT show to discuss digital twins, but also operational AI and other very interesting topics. We will also discuss how IoT, digital twins, AI all come together to deliver solutions that we were convinced were science fiction just a few years ago. And if you've not done so yet, please subscribe to the channel. That really helps us come back to see other videos like this one. Put a comment. This will really help us being more visible on the platform. Thank you very much. Hi everyone, this is the IoT show. I'm Olivier, your host. Today we will talk digital twins, and I think you've seen Bert in the past talking about digital twins. Bert, how are you?
I'm doing great. Thank you, Olivier. Happy to be here.
Well, thanks for your time today. We reconnected recently. We both used to work at Microsoft. We did a lot of digital twin things and more. And, I reached out and was like, hey, Bert, do you want to come and talk about digital twins? Because that's been a topic that I've seen kind of disappearing from discussions recently. It's all about AI and it's not about digital twins, but we'll talk a little bit about that today. First, for those who don't know you, can you give us a short introduction about yourself?
Yes. Hi, everyone. My name is Bert Van Hoof. I'm the CEO at Willow. And Willow is one of those key players in the digital twin space. And we'll have the conversation on how AI has become deeply intertwined with that topic. And to your point, I mean, it goes back and forth, but anybody who follows NVIDIA and Jensen, you'll have seen and heard about digital twins. So it hasn't really gone away, but it's certainly evolved. And we'll talk a little bit about hype cycles and those type of things as well. But exactly. We're alive and kicking. We've been at it for a while, and we're seeing some great breakthroughs.
Definitely. And a term that Jensen has been using is physical AI. That kind of triggered my thinking about, well, wait a second, physical AI means putting AI in touch with the physical world. So that means you need to put some structure on the data that will represent that physical world, right?
Yes, absolutely. Well, the other term that's come into play quite a bit now is operational AI. So that dovetails into that. Physical AI, often people talk about robots and those type of things, but sure. we play in the world of facilities, buildings, all the binding infrastructure. We can get deeper into what that really means, but now we get into delivering efficiencies into business operations, automating, optimizing, enhancing processes, right? That's the realm of operational AI. So definitely dovetails into that physical AI space. And I mean, you're right, where it gets interesting is that, as of late, a couple of very interesting conversations on, if you look at what Elon and Tesla and others are doing, there's the bits and atoms, right? So in our world as well, there are a lot of physical assets that we keep track of and monitor. And it's actually interesting. We just as a dovetail into that, which reminded me, we spent a lot of time refining our mission statement over the past while. And it goes, create a world where every building on the planet responds to the people, purpose, and environments they serve. And there's a very powerful statement in there because this physical world is, buildings are everywhere. I would tell people when you walk, drive, or fly around, what do you see? Buildings. Humanity functions in and around buildings, right? But buildings are not built to be buildings. They serve a purpose. And there's the people who then are part of that purpose and who operate or use those buildings. And then the environments they serve, there's always the bigger environment at large, obviously, which we all still care about. But then there's all the environments within a setting, right? So when people say buildings, they often, when I was at Microsoft and bootstrapped all of this stuff, people would think about the office they were in at the time or the residence they lived in, and then kind of lost perspective a little bit. But buildings are everywhere, right? An education campus, a hospital setting, a health and life sciences lab, a stadium or an arena, all buildings of specific size, office space, obviously airports and all the terminals, and that buildings are everywhere, right? And so environments within the enterprise or within an airport, the purpose is obviously a hub for transportation, but then you have all the check-in areas and security screening and boarding gates and baggage claim, and those are all environments within that physical world, right? So that's where the physical really becomes relevant, and where you start to see all the connective tissue. And it's not just about the myopic focus that the whole industry has had for decades now, which is HVAC and lighting, and mostly HVAC, and legitimately so. There's a lot of the energy consumption that goes there. But with Willow and digital twins and the AI space now in particular, we go well beyond that.
Yeah.
So that's the interesting part. Yeah.
It is. And we'll talk at length about that today. And what's fascinating about your short introduction here is that you just already brought in so many different concepts and ideas. And my brain is starting to think about, wait a second. So we're talking about a building like an airport, so huge building, but it has different environments in there. It has lots of different functionalities you want to achieve. It has lots of people. There is like people who are employees, people who are working there, people who are passengers, and you start thinking
you name it, right?
the amount of data that is required to represent in a digital format all of that. Yes. And then the second aspect, and this is where the digital twins conversation is interesting and comes in, the necessity to model and to feed these models of all of these things and to fit the data into, right? So that's where digital twins are coming from, basically.
Yeah, absolutely. Well, we used to operate in the same space, and we had these kind of conversations, right? When IoT became a big thing, we always joked it was like binary value, right? Where you had dumb physical assets, you add sensors to it, and now you get data and you can start doing monitoring and alerting. And, that was kind of the first foray into things. But then we started realizing, even when we looked at vehicles or buildings, or, you had to model the environment first and then look at where you could already harvest signal from a building management system that does HVAC and lighting and potentially one or two other things. But then also, how can you start to augment with new capabilities, right? There's a lot of activity right now around occupancy sensing. And that has a whole range, right? You used to have dumb, motion sensing, now all the way to AI cameras that do people count, or different techniques, not all just cameras. You have radar sensors and all kinds of things now. But to get this whole spectrum, and that then starts to enable, obviously, post COVID, the whole hybrid work situation and how is our space being used. But what's been virtually impossible without having something like Willow or a larger digital twin situation is, how do you start leveraging that to then say, how can I do occupancy-based HVAC control, right? If the space is not in use, those meeting rooms aren't used, or people aren't showing up to work in the same amount of volume and time, how do we just sense that in real time? And you overlay that with events that are part of calendaring and schedule in a hospital that can be, a system like Epic, or people in that bed or in that room or not. Classroom scheduling software, all these signals can come together where you can start to be smartly anticipatory, but also have that real world signal, and then start to throttle the HVAC behavior, have proper setbacks. If there's nothing happening, it's not anticipated, there's no real world sensing. And it turns out that saves tons of energy, helps you lower your carbon footprint. And so those are great examples of like that. It sounds like totally trivial. Why haven't people been doing this, for a long time? Well, because it's hard, that wasn't that easy to do. And you need something as sophisticated as a digital twin, and then all the way to the command and control aspect of it, right? We call that active control within our world. But to be able to do those setbacks and other pieces of control. You mentioned airports where we have things like water leak detection. So you start there. Well, then you can look at, well, when there is a leak, which turns out to happen more frequently than you think at a big setting like that. Well, where's the closest shut-off valve, right? People used to open the ceiling. Well, now you have a digital twin, and not always necessary to have that, but when you have the full BIM model and the 3D aspects, that technician can find it. But then the next step is, well, Willow, if you can now accurately detect or predict leaks, even when it becomes an acute issue, you turn off the valve, put the solenoids on it, and get the command and control through that shut-off valve. Right, so there are logical evolutions of how you can do those things, and that's where that broader digital twin view and understanding all these relationships, and even across systems, right? Like at DFW Airport, where we're active, you have the digital view glass, right? It tints digitally. You have the watt stopper lighting. You have the HVAC system. Well, when you tint the glass, that has an effect on the heat on the floor plate. It affects the lighting. So now I have these different systems that all need to dynamically interact with each other. So you need to understand those relationships. And so thus far, there's been a ton of IoT systems, many with a SaaS attached to it, but they all live on their own islands, right? And so that's been the problem on how do you make all these things cognizant of each other and understand the dynamics of it. So the physical world aspect, very important. Yeah.
But that begs the question, Bert. So lots of different systems, right? They're all using their own data formats and logics or meaning for the data. And digital twins is it's not a standard, right? It's something that goes way beyond just representing physically in a digital version in 3D something, right? It goes way beyond, as you just described, because it's about sensing that environment and acting on it. And making some sense of all that data. But in terms of interoperability, the digital twins being a concept and not a standard, how do we make all these different systems talk to each other and being able to have a relationship? And then, you're talking about shutting off a valve. Well, you better shut off the right one, right? And not another one in another room or place, right? So
yeah.
How do you address that?
No, that's a perfect question. That's key part of what we do, right? Because I even mentioned things like occupancy systems, right? And you may have Facet and VertSense and a whole bunch of different systems out there that come with their own data models, payloads, APIs. So the first thing we do is we model all this data of all these systems in what we call our knowledge graph. And that's where the concept of ontologies comes in as well. Right, ontologies aren't new. They've been around, certainly were around when we started Azure Digital Twins, were around in the academic world for quite some time. And so it's important, there is an aspect of standardization to that, but also extensibility in how you describe the physical world, right? You have Brick, you have real estate core, you have SIM in the electrical grid environment. You have NGS ILD in cities, etc. So there's existing ontologies that you can talk to. And on our website, we spend a whole section on explaining ontologies and why they are so relevant. But then as we connect to those systems, we collect, validate, transform, normalize, and model all that rich and complex spatial, static, and live data, we call it. And bring that all into the knowledge graph. And that then enables us to generate advanced insights with impact assessments, which we can come back to, and ultimately drive intelligent action, remediation, automation, right? This is where all the AI capabilities start to come in and now explode what we can actually do with it, right? Mm-hmm. An interesting backstory here is most of your listeners will probably be familiar with the Gardner hype cycle. And so at some point, I drew our own internal version of that. There is obviously one on digital twins. There's one on AI that everybody's following, and how Gen AI is going through the trough of disillusionment now in the one they just published. But we had our innovation trigger in 2018, and this was all about how do you get all that data together, modeled in this kind of knowledge graph, right? You capture the visual signal from the whole organization, the structures within it, label the data, put it all in a secure context, and understand the twins with the properties, the relationships between them. And that was great. And people looked at that around that time frame, 2018, 2019. There was this explosion of excitement around digital twins, to your point. And it was going to solve everything: world hunger, world peace, and some other gnarly problems. So you went to the peak of inflated expectation, right? People were like, oh, if I get all this together, good things will happen. And then you got through the trough of disillusionment slide, right? It's like, well, what does it actually do for me now, right?
Yeah.
What's the actual value and ROI? And so in Willow's case, we started building the traditional dashboards and analytics on top of that, right? And I would declare all of that as necessary but not sufficient, right? So, in the world of operations, you have technicians, operators, engineers. I would say engineers could look at time series data and make their own correlations, etc. But it was pretty hard. So it was not for everybody, and an average operator wouldn't get that much value out of it. So then we started probably 2.5, 3 years ago, what we now call our Activate technology, where we started to work with our AI skills, the first version of that, initially expert system driven. And that started to really move the needle. So you bring all that data, spatial, static, live together, you implement that with skills, you start to drive real intelligent insights with impact scoring, which we can come back to, very important concept within Willow. And that really started to move the needle in a big way. And then over the last 2 years, we've gone then on top with all the Gen AI capabilities now using LLMs or Willow Copilot. Because in the knowledge graph, we would also collect, when we say static data, that includes a lot of things like riser diagrams, single line diagrams. You may have test and balance reports for the HVAC warranty records. You name it, all of that comes into the twin, right? And that's something LLMs can feast on, of course. And secondly, there's the graph itself, that knowledge graph. And that's not that trivial for an LLM out of the box to just take advantage of. So we spend a lot of time on that. And that's driven a Copilot that's now incredibly rich, where you can ask all kinds of crazy questions, whatever comes to your mind. And it'll come up with answers. But you could say, hey, give me all the pumps of this type above 10 horsepower, and boom, you get your answer across 200 buildings in your portfolio, right? Or this pump has a poor carbon profile. So you go hunt, how many of those do I have? What would the retrofit look like? What benefits could I get out of that? So it's kind of endless what you can do with that once. I mean, there's a lot of talk now around AI ready data, right? So, and that's where knowledge graphs and twins come back into the mix as well, where you get that richness, right?
Totally. And all you just described seems, I can see actual scenarios what you're describing in real life, right? So as in me walking in an airport. Now I know IoT, and so I know where to look for, hey, there's a sensor there. And probably the temperature in this room is that because of these reasons and so forth, right? When you get the customs, like the lighting is not the same. You have like plenty of things that are controlled by this kind of infrastructure and systems. It took some time to get there, though, right? It's like not many buildings are that smart today, and it did take some time. The technology has been here for some time, but the complexity of putting everything together is where I would say the bottleneck is, right? And would 100%. You also say that we are in that middle ground between having everything DIY, where you have to create everything from scratch, from the IoT sensors all the way up to your graph and to your interface for working and operating the system, to SaaS solutions. And there's this middle ground, which seems to be working pretty well, which is very feature-rich modules that you will combine together, right? You can have an IoT solution for this, an IoT solution for that. You have the graph and model in the middle, and then you have a way to interact with the data. So are we in that stage of the technology where we can finally assemble bigger bricks that are more functional than what you used to have?
Yeah, no, that's perfect. Well, I mean, that's been our evolution, as I said, since 2018. Willow was born in 2017, but really popped on the scene with the product in 2018 in a big way, and early big adoption, SoFi Stadium, One Manhattan West, those kind of iconic structures. And it took a long time to provision those, right? So you had, the BIM models, you had the BMS, and then a gazillion other systems that you would have to model in it. So the whole setup and configuration took a long time. So in this whole journey, that's part of what's been perfected as well. So the whole concept of the independent data layer for things like a building management system and a protocol like Backnet, which typically is not properly normalized, can take a long time to get that squared away. How do you apply machine learning to that initially? And then a lot of cloud-to-cloud connectors with APIs, etc. So that's the data component. And then there's the modeling aspect, and how do you then bring that together with skills? When we say these skills, they automatically bind to that normalized data. That's where the ontology is relevant as well. So the system actually detects, this data is available in this particular form in the ontology. So now I can bind my skills to that automatically. And so it went from these things taking eternities to us now in 30, 60 days being up and running. And now there are new techniques when we think about spatial and static data in particular. How can we apply AI to that as well? Right. So we have, we recently just went through that in some demos with a test and balance report that's 3,000 pages for an HVAC system. Right. And so modeling that into our knowledge graph could have taken days, like literally by humans that are architects or mechanical experts, mechanical engineering experts. And so now you apply AI to that mechanism, including vision, for things like single line diagrams and riser diagrams, etc. And so something that took hours or days now takes a minute. And so that's a real democratizing motion on how quickly can you stand up something as sophisticated as Willow. You still need to have the original data sources for it, but once you have those, it goes way quicker than it ever used to be. And so that really allowed us to package and bundling these things up in what we call activate packs. So they're really, think of them as thematic value bundles that bring data connectors, ready to go connectors, together with those skills that then drive specific insights and value outcomes and those impact scores. Quickly on the impact scores, because I mentioned it a couple of times now, it's a very valuable concept in our world because a lot of people go by cost or energy, and there's certainly a specific type of impact. But there are many other things like carbon impact or productivity loss, right? If you have poor CO2 data, or your indoor air quality is poor, or your comfort scores are off, that has ramifications, and you can start to do apply models to that and have assessments. The wear and tear on your equipment, because it's not properly commissioned and is running basically not to the norm that it should be. Well, your wear and tear is going to go up. You're going to shorten the lifespan of that piece of equipment. We did things with refrigeration, which is a very interesting example of deep impact scoring, where think of a retail setting or a setting like distributors of medical things like vaccines, etc., that have refrigeration or freezing needs. When any of those units can't hold its set point or goes out, now the clock is ticking before regulatory requirements demand that you dispose of the content because it's no longer safe, or it's basically strict regulations around that.
Yeah.
Well, when it happens, you have all these ripple effects, right? You have inventory loss, you have supply chain and logistics ramifications because you have to replace something that wasn't supposed to be replaced. You have sustainability impact that now needs to be disposed of in a certain specific way. Sometimes candy by candy regulation, some of that becomes hazardous waste. You have margin loss. You have customer dissat because your meat freezer may be empty, etc. So we model all of that into Willow, and that means we can also start to correlate with what's the actual content of that freezer. so we know the cost of the content.
Wow.
And so it's obviously different for a cooler with yogurt versus something with Wagyu beef or vaccines in it, right? And so these impact scores are very relevant, and that drives what some of our customers call ownership mentality, where a technician isn't just fixing a compressor or condenser issue, but they know the clock is ticking. If I don't
Yep.
get to this problem within 2.5 hours, it's going to cost my employer 20, 30, 40 grand because that content will have been disposed. And so job satisfaction goes up, impact goes up. You can start doing gamification around that across the workforce, etc.
Nice.
So
Nice.
yeah, that's a
And
cool concept there.
th-
But coming back to the bundling, so that's these activate packs or the data plus these skills with the impact, and that then drives action and value outcomes. So they're thematic. We have one around sustainability, one of it's called building energy and operations, occupancy, active efficiency. That's where you bring in solar PV, EV charging, battery storage, those type of things, asset condition monitoring, even on-site food preparation with kitchen equipment, right? People don't think about that, but turns out kitchen equipment you find everywhere, whether that's a superstore or you go to a stadium where you have concession stands, or you're at DFW airport at the restaurants, or the two distribution center size facilities that do catering for the planes. You may have pizza ovens, rotisserie, oil waste ovens, high energy consumption, right? And all these things can be
it's
more
crazy.
connected.
It
Yeah.
it is crazy. It is crazy, and one can just imagine how hard the integration of all of that, is. And so leveraging tools that allow you to not just do that integration, but automate some of that integration as well with all the packs you just described. That's pretty crazy. That begs a question around security and compliance. You already touched on that. But to me, these are also some of the super important advantages of making sense of your data in an organized way, right? Because you can gather tons of data. Big data is something we talked about like 20 years ago already. But one of the big touchy topics with many of my customers implementing the IoT parts of systems, they are concerned about securing the data. There's IP in there.
Yeah.
There is confidentiality. There is privacy concerns. How do you see, digital twins solutions around like Willow's addressing these particular topics of security and compliance?
Yeah, I mean, there are many layers to that, of course, but it's a requirement to get all the value that you digitize, and you have to digitize responsibly, right? And it's very important when you shop for a vendor like Willow that you look at the security capabilities for ISO 27001 certified, SOC 2 Type 2. So that's very important. Interop with tools like Defender for IoT or RMS, etc. Right. So as I mentioned, there's multiple layers of defense here, but it's definitely an important component. But certainly that integration layer in and of itself should think deeply about security. We spend about 3 months every year with a good amount of people to recertify for those two certifications specifically. We take that very seriously. So do our auditors. And so yeah, that's a big deal and not to be underestimated.
And now let's go into maybe as a last piece of topic, things that are maybe more science fiction, and they're kind of related to security in my mind. When you put some AI on top of all of that, now you have a digital representation of an environment, of people in that environment, or the functions of the building or rooms or whatnot. You put AI on top of that, and we all know, what AI is capable of, and so it helps a lot by automating a lot of things and so on. But is it something that we should be a little bit concerned about, that now everything is digitalized, so that means that everything can be automated and can be taken control of? And I say AI could be someone
Yeah.
was like ill intended as well, but at the end of the day, in that future world, how do we make sure that AI is actually put to good use and in that context of everything being digitalized?
Yeah, I mean, you have to go about it very conscientiously. I mean, I mentioned the active control and doing command and control, even for something as simple as occupancy-based HVAC control. We always start with human in the loop, right? You have to provide the infrastructure where people can test drive this. They always have to approve the change before it actually goes into effect. And then what we see for those kind of scenarios, that they're pretty robust, more than pretty robust, they're very robust. And so people run that for a while and then they go like, yeah, now run, right? Now you have autonomous system behavior for that chunk of activity. But so you can infinitively expand that, always starting with that human in the loop component. For anything in the physical world, that's definitely essential. But people then quickly discover that there are low hanging fruit scenarios that have limited risk and much more upside. And so that's where you start, right? So that's one component. But then with things like Copilot, I mean, that's where it gets really interesting. Um, we do the hints in the context of the UX of the product as well, and so you can you can quickly jump into logical questions you would want to ask about the data you're staring at, and then you get amazing answers and follow through questions and hot links to elsewhere in the product, etc. Um, composable dashboards. Like I do believe the traditional dashboards are, probably going the direction of the dodo bird, right? It will be
Yeah.
way more dynamic, where you can start with a prompt and say, oh, okay, this is something valuable that I would want to keep staring at. So you'll see more and more graphics and stuff like that coming in. Not all of that will belong in a chat window. So you'll see some of that into composable dashboards, but that are prompt oriented. All those type of things are happening in real time. So, it's as people often say when they talk about this, sometimes we overestimate in the short term, but we underestimate in the long term.
Yeah.
This will be absolutely game changing. There's no question about it. We now see customers at different levels. They can be technicians, but they can be CPOs or CFOs starting to experiment with all kinds of questions. And then initially we were like, ooh, let's see what comes out of that. and increasingly, there's always some really amazing answer coming out, and people get more and more enamored about it. We did a couple of blogs.
It's alive. It's alive. The building is alive.
Yeah, but you can really start to live interact and reason with your data, and it's very valuable. As I said, we have this graphic on how you train the skills, as well as you have different domain experts, right? So initially we were very technician focused, but now you can have operators, real estate and facility services people, but sustainability, chief sustainability officer, or people who work in the field, people who work on energy transformation, security people, finance and HR people can have interesting questions, right? And so it all depends on the integration.
Are you saying, Bert, that Gen AI is democratizing digital twins and all the complexity that is behind it, right?
Yeah, I think that's right. I mean, it's that's what's creating the breakthroughs, right? As I said, anything that happened before was necessary but not sufficient, and this is really driving scale, and the democratization is really the right term. And then the SaaSification of it all, and this ability to have these pre-configured value-oriented bundles to step in and say, oh, I'll start with sustainability and building energy and operations at the more traditional entry points, right? Yep. I get an ROI on that, and it's like, now what else you got, right? So, and you just peel it off. And so, we don't charge setup costs at all. So it's a true SaaS from that perspective. People come in, they transact on these Activate packs that they want to start with. We get up and running very quickly. We show ROI, and people level up. They either go more buildings, or they either go more Activate packs, or both. There's a whole runway of value to be unlocked.
I love that. And that's interesting, Bert, and that's going to be my closing word, and I will give you yours as well. But we've been talking a lot about technology in the last 20 years, technology, individual ones, right? IoT on one side, well, it started with embedded, IoT on one side, digital twins and cloud platforms and SaaS and everything, and AI and Gen AI, and everything is coming together I don't know what's going to be next, but everything is coming together as, oh, remember that thing called IoT? Now we can use it, right? It makes sense
Well,
now.
that's the irony a little bit, right? I mean, we bootstrapped a lot of that world, and
True.
yeah, you could argue that only now with these capabilities it's coming to full fruition, right? Because there was always all these investments and kind of the same problem. Now what, right? And the traditional.
Let me ask you now, what's next, Bert? What do you think is next in our domain?
Yeah, well, I mean, it's as I said, some of it starts now to lead a life on its own. I mean, these kind of rodeos are never done, right? And we stand on the shoulders of the frontier models as well. And Microsoft's a key partner of us. We have a vibrant co-sell motion there as well, but we stay connected at the bleeding edge of things. Some of the capabilities that I mentioned, right? We started with OpenAI and ChatGPT 3.5 Turbo with Vision, as it was called, when we first started to experiment with the Vision AI and see, hey, all this time we spent to model this thing in the knowledge graph, could we leverage the LLM to bootstrap this? And at the time we had very simple diagrams that yielded something where you could squint and say that could lead to something, and then massive hallucinations on the typical kind of things that we would ingest, right? And then fast forward through multiple iterations, two things happen. One is the frontier models got a lot more capable in that regard, and then two, we overlaid our own IP, partially with multi-passes through where you look for certain things, where you really train the whole thing to, this is where the agentic aspect comes in as well, right? Reason through a single line diagram for plumbing, like a plumber expert, right? Or a plumbing expert, or an electrical diagram as an electrician. And so that's where things got profoundly better very quickly. And so some of the unique IP overlays we did initially, we could eliminate, but you're constantly redoing, constantly retesting. It constantly goes faster, it constantly gets better. But it's to the point now where some of that is quite sophisticated, and that'll continue to evolve, right?
Yep.
So
Yep.
obviously the model is trained on synthetic data. So, people a little while ago, they were like, oh, it's all going to max out. All the world's data is ingested already. And yeah, now it turns out not to be the case. Synthetic data will continue to push the frontiers, and good for them.
Let's push the frontiers. Love that. Awesome. Bert, thanks a lot for your time today. There's so much more to talk about that we have to stop at some point, unfortunately. Yeah. But thanks again for your time today. And maybe we'll dig into this topic again with you soon on the IoT show. Everyone, thanks for tuning in.
Absolutely. Thanks so much.